Okay, today we go into a new chapter, chapter 8. Hmm. Today we go into CO3, analysis of trust. So basically, this chapter you already know. Uh, just go very fast. I'll just show you the example. The rest of the concept you already know. So for this chapter, we are using the equilibrium equation. This chapter will be on the application of all the force equals 0, all the moment equals 0. Okay, this is called equation of equilibrium. Later, you'll see different kind of shape. You call truss. Truss is a support. It's a structure support. Then we'll use method of join to solve the things. And then the rest is follow. So this chapter, we focus on method of join. Okay, method of join. By using F equal to 0, moment equal to 0. But now we focus on join. Right. Okay, what I mean by truss? So this word is very popular in civil engineering. Truss is members that join together at their endpoint. Okay, something like this, right? This is called truss. So if you see a truss means they are connected with something, with a screw, with a pin or something. Then they take over the stress or loading. Okay. So of course, in the exam, we won't ask you what is truss. You straight away see truss and then you do analysis. Okay. Okay. So this is just explanation on what happened to the truss structure. The weight of this roof will press on the members here, and later we'll do analysis what happened to the member. So the objective of today's lecture is to see whether that particular member is in tension or in compression. This is our objective. You need to use all the force equals 0, all the moment equals 0. Then you use moment of join to decide whether the member is in tension or in compression. Okay, this is the objective of today. All right. Okay, the rest you'll read. So this is in the 3D form. We call it simple truss. So in the previous lecture, you see this one as a cross section, and you view from this side. You are seeing 2D diagram. Okay, so this is a 3D diagram. I think those taking civil, you already know what is stringer, what is floor beam, and all this. But for mechanical, stringers is the one that connect body to body, usually in the longitudinal direction. Floor beam, they connect, is a member that connect the longitudinal member. Okay, so we can do this kind of simple truss 3D dimensional into 2D. Okay, into 2D. So if you transfer this pin here to this here, so this pin will be, let's say we have this point on the left here. We just say that this one, you have y direction force and x direction force. Okay. Whether to the left or to the right, in this case, doesn't matter, because when you do analysis, you will find whether it's positive or negative. So if you are pointing to the left, and when you do analysis, the result is positive, then is agree with your free body diagram. If you're pointing to the left, then you do analysis, you get negative, means the one that you draw in your free body diagram is wrong. You need to flip the direction. Okay. So why this one pointing up? You should already understand already. This one, point A, is a roller connector. So a roller connector only have one things. Then the rest of here will be because of the weight from the body. So this one will pull down, pull down, pull down, and so on. Okay. All right. So this one also same. All right. Also same. The roller. This one also roller, but this one is a pin, and so on. So this is just application of what you learned in the previous chapter. Okay. So again, now we want to learn whether the member, this section or this section is in expansion or mean in tension or contraction, compression, right? Okay, these are the assumption that we have. First assumption in design. So when we want to do force analysis, we assume something. First, all loading are applied at the joint. Okay, so this is the assumption. When you do structure analysis, we focus on joint. All loading apply to the joint. It was transferred to all the joint here. Right? Especially truss, especially bridge truss, the word truss here. Truss is a connected member that transfer the load from one place to another place. So if the weight is to be included in analysis, it generally apply as a vertical force with half of its magnitude applied to each end of the member. So this one, you just say that if you need to consider the weight, you need to take this weight, divide by half. Take this one, divide by half. It just means like this lah. So this is half W, if there is a joint there. Okay. Okay. Second assumption, all members are joined together with the smooth pins. Means we don't consider friction at the pin there. So they are joined with pin. Smooth pin. Okay. So first is all the force go through the joint. Second one, we are using pin to connect all the members. So what I mean by pin? When you have a pin on the member, let's say this member. So when you have pin here, you convert into free body diagram. What do you see in this? You will see these two forces. Right, let's say this is A point. So you have AY, AX. Yeah. So this is this chapter. If the question asks you to apply method of joint, means these two apply. These two assumptions apply for chapter 8 question. Okay. So if the question forces you to use method of joint, these two assumptions apply. Means all the force were acting on the beam, on the joint, all loading applied to the joint, and you are using smooth pins connected by smooth pin. So these two. So automatically you see pin, you convert into two forces like this. Okay. Pin are free to rotate, so no moment. Okay. So something like this. Some they give board something like this. So this called gasket plate. This called gasket plate. So get familiar. You will see this word in the assessment. So gasket means it like do like this. So there are four forces. All forces, it depends on whether go up, go in. Right? There are some certain steps I will going to teach you. Okay. So some member, something like this. Okay. So for chapter 8, the question normally it will give you one pin loaded, then you need to do analysis for whether the arrow point out or point in. Because the arrow point in, point out, it will tell you at the end, you need to tell me whether the member is in tension or is in compression. You need to tell me at the end, you need to tell me by using your calculation. Okay. So these are the metal gasket, but gasket in the normal application, right? Okay. So because of these two assumptions in our analysis, we will treat each truss member act as two force member. What I mean by two force member? Meaning the force can transfer in the straight line. Okay. So remember there is a tutorial question in the previous chapter. One tutorial question. Remember to go and see. There is a two force member in the L shape where when you do analysis, you convert stress like this. Yeah. If you haven't read the tutorial, make sure you go and read today. Okay, so this is the two force member, either in the tension, which is tension means force pulling both end. If it's compression, means the arrow pressing both end. And we will use T and C in our answer. If you see capital T, if you write bracket, T means that is a tension member. If you write C, means that member is, or that member is a compression. Okay. So often compression member must be made thicker. This is on a structure design. So because when you compress, you make the member become thicker than the tension member because buckling or sudden collapse will happen. Okay, when you press the two force member, it will buckling. Buckling means change shape like this. Like this. Or some like this. Okay. So let's start with the simple truss, triangular shape. So if you have three members joined together with the pin, they are formed triangular truss. Okay, so given ABC and you have the connector here. So A, you should able to draw the reaction force. B also you should able to draw the reaction force, right? And you have an external force P here pressing down here. Okay. So without further analysis, you should able to imagine what happened to the member AC, CB, and AB. If you push P downward, what will happen to AB? If you push P down, what will happen to AB? You just imagine. It will be compressed or tension. It will go longer, right? So tension. I mean, this is your hypothesis. So later you check the answer, whether it's tension or not. Then you press P, AC will be, it will buckling, right? It will buckling like this. CB either this way or this way, right? So it will be compression. Okay, so this is your hypothesis. Before you start, you imagine a bit. Then after you analysis, then you check back whether the logic or not. If you're not logic, then maybe your positive negative sign is wrong in your calculation. Okay. Okay, so attaching two more members and connecting them to a joint D form a larger truss. So you can extend this triangular into another form like this one. You join, you recreate one more new point D by two more members. Okay, this is another strengthening mechanism to distribute the load. Okay. Okay, so this one you can repeat as many times as you want to make the structure stronger and stronger. All right. So we start to introduce you the method of join. So if the truss is in equilibrium, means this one, all the force equals zero, all the moment equals zero, then each of the joint is also in equilibrium. So you look at the joint, if out of this joint, the forces at this joint will be equilibrium. Okay, so let's look at this example. So you have ABC with 45 degree, 2 meter from A to B with the external force 500 Newton. Distance A to C is 2 meter. This is the pin. So you have AX, AY. C is a round shape here, so they only have CY, don't have CX. All right. Okay, so before you analyze, you should able to imagine what happened to all the members. If you pull 500 to the right, this one will bend here. This one will buckle. This one will extend to right. Right. So before you solve, you should able to imagine what happened to the member if you have this kind of scenario. All right. Then you prove your analysis using numbers, using equation. Okay, free body diagram. We start with one point that already given you the numbers or external force. Okay, the steps always start with one point or one pin that you already know the numbers. For example, point pin B. Pin B is, you know, the 500 Newton. Okay, 500 Newton. And FBA and FBC at this moment, we do not know whether it's tension or compression. Okay, but you can imagine when you pull to the right, you actually make AB, this point, become longer. It will bend to right. Okay, this member. Okay, member BA. Remember to write the sub numbers here correct. FAB and FBA are a bit different. So because you are dealing with vector have magnitude and direction. So if you write BA, it means B to A. If you write FAB is from here to here. Okay, same with this one, BC. So BC, you pull this one. If you are B pin, if you are pin B, you're actually feeling the BC member pressing on you. So you draw this one. So of course, at this moment, you can draw whatever direction you want. Of course, you cannot change the 500 direction. The rest two, you can still flexible. Because later when you do analysis, you will know whether positive or negative. Okay. So this effect can seen by isolating the joint with a small segment of member connected to the pin. So you take away all these member and you see what happened to the pin. You just imagine you are sitting at pin B. What do you feel? Okay, what do you feel? Okay. So these are the, if you draw the bodies, you will see actually it's the same. You just extend the members lah. Okay. Okay. So when we have all the force into 0, all the y equals 0, means all the force equals 0 by using equation of equilibrium. We are now using method of join. Method of join, we focus on pin, and we assume all the members are two force members. Okay, so all the force equals 0 here, you can extend to x, y, and z direction if it's three-dimensional. Okay, it's 2D. This one, you need to be careful. Sometimes the question will just trick you, right? This one, Z and Y. So you need to read the question carefully. Not usually X, Y. Sometimes the question will put the axis there, Y and Z. So when you write your equation, follow the equation, follow the question. Okay. So you should able to solve if you have all the force equals 0, in X direction 0, in Y direction 0. You should able to solve already. This one got two unknown. You should able to solve. Who don't know how to solve? Who don't understand what I'm talking? Okay, nah? Understand? Okay. Okay, so sometimes the correct sense you can use by inspection, right? So BC must push the pin since the horizontal component need to balance this one. So if you have one external force, you split into y and x. Okay, you split into y and x. So your x must FBC x direction must balance 500. All right. Then this one must balance with these forces FBC y direction. This one you can check by using inspection. Right. So the force must be balanced each other. If not, then the member will move to the left or to the right or move up or move down. Okay. In static we assume everything in equilibrium. So if your force is not balanced, is not static question. It's go into dynamic already. Okay. Okay. So again, if in a question you really don't know, you can assume. Then when there is a negative, then means what you assume is wrong. You need to flip the direction. If you assume you get the answer is positive, then what you assume is correct. Okay. So this is just tell you lah. If you get positive answer, means what you draw in your free body diagram is correct. When you get negative means you need to redraw the free body diagram. Okay. So when you answer this kind of question, if you assume wrongly, if you draw like this, this is wrong, so remember to bracket wrong and draw a new one, or you can cancel this one. Okay. So don't let me choose. In the exam, if you let me choose, I'll choose the wrong one. Okay. Don't leave this answer to me. Like this one. Don't leave it for me to choose. I will choose this one. Okay. So if it's wrong answer, then you just mark it as incorrect answer. Then you continue with the calculation. Okay. So this is a guidelines. Always assume unknown member force acting on the members on the diagram to be in tension. The force pull out from the pin. If you really don't know, you assume everything point out, the arrow point out. Then you calculate, you get negative, mean you flip back the arrow. Okay, if you don't know, if you really don't know. Same, okay. So this is just a general guidelines. If you really don't know, all the unknown arrow, you point out from the pin. Okay. Okay, then after you know a form already, use P or C in your answer. I will show you in the tutorial. So let's say we take this diagram to do analysis. Determine the force of each member in the truss and indicate whether the member are in tension or compression. So if you see this kind of question, it asks you to indicate whether the member is in tension or compression. It is in chapter 8 question. So in chapter 8 question, remember you need to use method of join to solve. Just for your info. You don't see indicate members are in tension or compression in other chapter. It's only apply in chapter 8. Okay. So in this kind of member, first what you do, same, you draw free body diagram. Okay. This is just for this one. But you just so since we should have no more than 2 unknown forces because this is 2D diagram. So you should not more than 2. At the joint, at least one known force acting there. We will begin analysis at D. So here you have 2 unknown. Here you have 1 unknown. Here you have 1 unknown, 2 unknown, and then 1 known value there. So that's why you pick point B and not point A and C. Okay. So we draw the pin B at like this, right? So in this case, why FBC is pointing to the B? Because we use the inspection methods. There are two methods, either inspection method or you use assumption. All the arrow point out. Okay. So in this case, we assume is FBC pointing inside the B and FAB pointing out with 45 degree. So you should be able to solve what is C and AB, right? Okay. So all the force equals 0. So what is FBC? All the force in X equals 0. And moving to the right, positive. Remember to draw this one in your answer. So 500 Newton minus FBC sine or cos. Sine or cos? Huh? Yeah. So in this case, if you draw like this, you already draw this free body diagram. FBC equal to this is sine. Huh? If you give this free body diagram, your answer is sine. Okay. Then equal 0. So you're able to find what is FBC equal something Newton. So press your calculator. What value you get? 107 point. 707.11 Newton. Right. I don't know. You press. Okay. Y go up positive. All the force equals 0. This one is bottom. You need to write this one. Then only you write the okay minus FBA plus FBC cos 45 equals 0. So you substitute this one here, you're able to find FBA. Yeah. Okay. So in chapter 8, remember at the back of your answer, please tell me whether it's a compression or tension. You look at FBC, the word C there, because FBC are pressing into B. And FBA are pulling the B, so that's why it's T. We are now focusing on pin. Later, I will ask you members. Don't confuse. The question asks you whether is tension and compression. We are now looking at pin B. Pin B. We'll look at pin now. Okay. Okay. Anyone have question on the T and C? Anyone have question? No. We are now again. We are now focusing on pin. Later we'll move this. We'll move this solution into members. We'll now look at pin first. Then we'll transfer this answer into the members. Okay, we have found B. We can move to C. How you draw C? By looking at your pin B answer. How do you draw pin C free body diagram? Pin C have what? CY. And then, if you don't know, there's one force here, which is force AC or CA. And then, member C is what? FBC is pointing in or pointing out? Huh? So what you should draw here? Draw like this. Okay. Why you can draw like this? Because you have two force member. You assume it is a two force member. Okay. So in this case, you will see something like this, what you see on the screen here. Pin C, CY, FCA, and your FBC. If you're not sure 700.1, you're not sure this answer, please write FBC on the top here, if you're not sure. If not, it will snowball the wrong answer to the next one. If you write FBC, but if you calculate the wrong answer, there are two types of answer. For example, this is C. If this one I calculate, yesterday I calculate wrong. I calculate 600 Newton for this one. And another student, he write answer like this. This one is wrong answer, but this one I will give correct answer. Yeah. If you're not sure your numbers, I recommend you write the members notation. Yes. Yes. Yeah. Yeah. Uh-huh. Uh-huh. Uh, in this case, because you are dealing with B to C, it's just that the arrow is pointing to that direction. Yeah, it's in the B to it should be CB, right? It should be pointing from C to B. But anyway, if you write CB or BC, to me, it's not a big issue. In this case, okay. Important is you are looking at the correct members. Okay. In this case, the BC, AB, this one is the member. Okay. Okay, then you solve using equilibrium also. All the force equals 0, all the moment equals 0. So x, you need to tell me where is x positive, where is x negative, y positive. Okay, do the same. You will get CA and CY. Okay. Let me know if you don't understand what is happening on the screen. Okay, so FCA is pointing to the left, is pulling the pin C, that's why it's tension. Again, we are now focusing on the pin. But however, CY, why there's no C or T there? CY, why there's no C or T there? Why? What is C? What is C? C is a connector. Connector is only, yeah, it's a devices lah. So it's not a member. Cannot elongate, it cannot compress. So don't go and add C and T for the reaction force. There's no reaction force at the connector there. Okay. Right. So although it's not necessary, you can determine the component of the support reaction at A if you want. So this one usually you need it in the final exam or test 2. So sometimes the question will extend from here, ask you to find what is the reaction at A. You should be able to find because you already have CY and B here to find the AX, AY. Okay. Don't confuse with the pin, don't confuse with the pin and external forces. Don't confuse. Okay. So then you solve C, you can find A, right? So A, you have forces pointing to the right, FCA 500, FBA 500, and then there's AYAX. Okay, this one is a common sense. The direction of AY and AX, it must be balanced FCA and FBA. This is common sense. Although AY commonly is pointing up, AX commonly pointing to the right. But to balance, you know that when you do all the force equals 0, AX will point to the left, AY will point to the go down. Yeah. So if I point A, initially you will find FBA point up, FCA point to the right. You can still draw something like this if you want. If you want. But you will find AX, AY negative value. Redraw this one. Redraw this one to AX, AY. Okay. It can in the draft, in the early solution, you can draw like this. But after you do analysis, you will get AX equal to negative something, AY equal to negative something. You need to flip this diagram into this one. Because in the free body diagram, there's no negative value. There's no negative value in the free body diagram. The one that you see on my slide, some slide you see negative in the free body diagram. That is to show you the changes of direction. But in the real solution, you should not put negative one. Yeah, so don't confuse with the slide. Okay, so you solve, you get A, you get Y. And again, you don't see AX, AY with a C and T. Capital C, capital, because we are reaction force. They are not members, they are not Truss members. Okay, remember that. If your hand is so itchy, I go and write CT, I will circle and give you discount. Although the numbers is there, like for example, this one is 2 marks. If hand itchy, go and write C and T. I will circle this one. I gave you wrong, I give you 1 mark. Correct answer for the number. No. No 0.5 mark in my marking scheme. Either you get full mark or no mark. If you write like this, then you get 2 marks. If you go ahead itchy, write C, T, or then got 1 mark. Means you don't know what you are writing. Yeah. It is a very serious problem when you go into dynamics. Okay. So this is good to start from statics. Okay. Okay, so then you need to, at the end, when you do all the pin, you need to summarize with this diagram. You need to draw this diagram in your final answer. You draw the pin, copy the answer, the arrow point in or point out, copy. Then the next, you need to draw the members. You draw the members. And as you can see, when you draw the members, you need to flip the direction. For example, pin A point up. This member here actually need to opposite the forces. So same in here. So when you see this one, two arrow point up, this member is actually in tension. Okay, this one is in compression. This one is in tension. You need to flip from the pin, you flip the arrow onto the members. The question asks you members, not ask you pin. If you stop at A B C pin, you're not answering the question actually. You need to arrive at this diagram. Yeah. So in the exam, don't give me lines. Don't give me please draw the bodies. Please draw the bodies. Please draw something like this. Not this one. Okay, draw B, A, something like this. Okay. So any question for example one? No. Okay. So this one, I just highlight here. Remember to summarize your answer. So I go to when I check, I will just go to the last one. I will see whether the value is correct or not. If value is correct, normally I'll just give you full marks for the answer, for the question. I'll just still go back to check your steps. But if your answer is correct already, means your step normally is correct. Okay. Okay, example 2. A bit complicated, but it's the same approach like just now. So determine the force acting on all the members in truss shown in the figure. Indicate whether the members are in tension or compression. Again, the question highlight members, not pin. Pin is just part of your process. So here, you start by imagining what is happened to the members. If you pull B, this one stationary, C can move. So it will behave like example 1 just now. So you pull B, this one will actually, if you move B, this one will move here. It will like this, right? BD will move to will rotate to the left hand side. It will bend like this. So when this one D move to the left, this one will pull, right? So this one will pull, C will move to the left. Okay. So this one cannot move. This one cannot move. So B move to the right. This one will buckle. So you know that AB will be in tension. Just a common sense. So BC, you pull this one move to the left. This one will buckle, and so on. So you start with analysis. You see, so you need to be smart enough to pick the correct point to start your analysis. You start with what analysis? You start with the known point with the known value, and then two unknown. Two unknown with one known value. A, you don't know. C, you don't know. B, you have a known value with 1, 2, 3. Okay, so you need to start with external force first. Okay, so the external force, you should able to find AX, AY, and CY. You should able to find. This one you already learned in the previous chapter. Okay, all the force equals 0, all the moment equals 0. But in this case, it's very straightforward. What is the value of AY, CY? If you are not given any mass for the members, 0. AY, CY, from this case, you know already 0. So you can write here in the free body diagram equals 0, equals 0. Okay, so your homework lah. Wait, not 0. Okay, there's a value for Cy. Y is not 0 because there's a moment force there. You put your hand here. Cy actually generate moment. Here. So 3 multiply 2 and Cy multiply 4 must equal 0. So not 0. Not 0. So just your homework. No. So you arrive at these 4 value. Okay. Just be careful. All the force equals 0, all the moment equals 0. Do the external force first. Then you start from C and not B, because why? B you have 3 unknown. 1, 2, 3. 3 unknown have 1 known value. That is not what we want. So C you have 1 known value and 2 unknown. 1 unknown here, 1 unknown here, and 1 known value. Here A you can also start with A also if you want. But A you have 2 forces and 2 unknown. It will be more complicated than C.
So are we treating the whole object, like the whole truss system, are we treating it as one object to find the
External force.
So we just treat it as one object.
To find the external force. To find the external force, you assume is one object, like what you did in the previous chapter. Okay, once you find the external force, the reaction force, only you do the members. Yeah. Okay. Now we go to choose pick pin C because it's more simpler than A. Again, you need 2 unknown to use the method of join. You need 2 unknown. You need 2 unknown and 1 known member, 1 known value. Okay, this is the approach. Okay, we start with pin C. I will straight away give you the answer. Remember to give the axis X and Y, and then copy the shape. You have 1.5 kilonewton, or if you don't know, write Cy. Or if you're not sure whether you get 1.5, write Cy first. Then only you substitute. So 1.5, and then this one, this member and this member. F, BC or CB, and CD or DC. So how you know whether it's pointing in or pointing out? You imagine you are the pin C. If you're pulling from pin B, you're feeling this member BC pressing you. If you are standing here, you pull from B, you will feel this member BC is pressing you. When you're pressing you, the arrow is pointing to the C. This one, it will, you know that BD will rotate to the left. This one will pull out from C. So that's why the arrow point out from C. Again, this is just a common sense. If you really don't know, you just draw every arrow point out. If you really don't know, then you get negative, then you flip back. If you really cannot imagine, so just highlight lah. It's important you can imagine. If cannot, then just everything point out, then do analysis. Okay, applying again, all the force equals 0 or all the moment equals 0. Pin, why there's no moment? Because pin is smooth. Pin is smooth, it's free to rotate, no moment. You put in all the equation. You are solving 2 simultaneous equation. 2 simultaneous equation. So you know sine divided by cos equal to tangent. Okay, I'll straight away give you the answer. So at the end, you arrive at FBC equal to 5 point something kilonewton And then remember, if you're looking at the member, remember there is a T or C. So FCB is FCB is pressing, so it's compression on the pin. On the pin is compression. And FCD is pulling out, so it's tension. We are now at the pin, not member yet, at the pin. So you do the same. Once you have C, you move to another member. So because this is a symmetry member, you go to the D point, you move to the D. You move from one pin to another pin. So you look at the question, if you have 4 pins, you need to have 4 diagrams. Every pin you need to do analysis. Okay. Usually in the final exam, you want more than 6 pins. You want more than 6 pins because you only have 30 to 45 minutes to solve one question. Because you have 2 hours to solve 4 questions, it's about 30 minutes maximum. Okay, so D, you have 2 members and 1 member point out. So you have 3 unknown. 1 you already solved, and you have 2 unknown. So you can continue to solve. Make sure every time you do solution, you only arrive at least 2 unknown, 2 unknown and then 1 known member, like this diagram. Then only you can solve. Okay, if you have more than 2 unknown, then you cannot solve. Okay, why you cannot solve? Because you only have 2 equations to use. F equal to F equal to 0. You only have Fx equals 0, Fy equals 0. You only have two equations. So you maximum you can do is 2 unknown. Okay, do the same. You can solve for dA and dB. Okay. Anyone at this point you still don't know why there's a T there? Because the arrow point out is pulling the pin tension. Again, we are now at the pin, not member yet. The rest you read. Okay. So the rest, again, I already skipped the final steps. You need to draw the final, break everything, then draw the either in or out. Ah. Mm, not symmetry because the support is different. If you get the support is the same, then yes, it can be symmetry. But again, this one, the forces is pulling to the left, then it's not symmetry. If the 3 kilonewton is pressing down, then yes, symmetry. Or pulling up B, then symmetry. This one is not symmetry. The structure is symmetry, but because of the force, it make the case is not symmetry. Okay. Okay, maybe we go fast a bit. So the rest you read. Example 3 as your homework. All the answer is there. Okay, all the answer is there. You see that the trend always same. Solve external force, then go to pick one pin that have 2 unknown, 1 known value. Then you start from there. All the force equals 0. Then you find one member and then look at the arrow. Remember to put C or T at that member. If it's a reaction force, then no C or T. Now, for example, this one. CX, CY, AY, all these are the connector or the reaction. No C and T. Don't go and hand itchy, go and write C or T and that one. Okay. Number 3, done. We want to introduce you one zero force member. One member called zero force. Okay, so truss analysis we can simplify by identify those with no loading. No loading means zero force. All right. This is to increase the stability of the truss during construction and provide additional support if the loading is changed. This is for construction design, construction structure design. Okay, so this one you can done by inspection, or you can do by hypothesis. Okay, so for example, you have this kind of truss. Key pull down. There's a roller ball here. There's a truss here, a 90-degree here with the angle. So you should able to change this as a reaction force. B point out, By. This one have Fx, Fy. And this one pull down, you should able to find, to imagine what happened to all the members here. So if you need to do analysis, you have 1, 2, 3, 4, 5, 6 pin analysis. Okay. So for example, you pick point A. Point A, all the force equals 0. You will see that FA, FB equals 0. You pick this point and all the force equals 0. Force AF, force AB equals 0. So that is a 0 member, 0 force member. Okay, so this is to identify the 0 force member. So sometimes the question from the A part, you do the analysis already. If you find F equals 0, that is just mean that you already found the 0 force member. Sometimes the question will ask you identify 0 force member. So from your analysis, all the force equals 0, what? They are 0 force member. Okay, yeah. So this one is just a remark lah, just a remark. So if you do analysis, sometimes it won't tell you that actually it's a 0 if you do complete analysis lah. Okay. So pin D also, pin D, if you do analysis, you have X and Y axis added. So you can find that D is 0. So DE, DE, this also 0 member, 0 force member. Okay. And DC, DC. Okay, if you arrive at this equation, FDC sine theta equals 0, you have two components. One is FDC, one is sine degree. In this case, degree cannot be 0. So this one cannot be 0, then FDC must be 0. This is mathematics. So also common sense. If you look at the diagram, angle cannot be 0. So FDC is 0. So this one, some careless mistakes usually. Okay, so to summarize, this is a guidelines. If only two non-collinear members form a truss joint and no external load or support reaction applied to the joint, the two members must be 0 force member. I mean, this is a guideline to observe where is the 0 force member. So if you see AB, this one, AF and AB, so only if two non-collinear members form a truss joint and no external load apply to the joint. So for example, A don't have external force, don't have reaction here. Okay, and they form a truss member. So this one, AF, AB is 0 force member. How you know this one and this one is 0 force member? You look at pin D. Pin D also don't have any external force, no reaction, no support here, and these are the two members with the pin here. So these ED or ED, DE or C, DC or CD, they are 0 force member. Okay, so these are the first guidelines to spot 0 force member. Of course, you do analysis. If the force equals 0, means it's a 0 force member. If you want to prove it in mathematics, if not, then you just use these guidelines or this statement to spot where is the 0 force member. Okay. Okay. So you can simplify this look like a complicated problem, simplified by this problem. Okay. So the kind of question will come out like the first section will ask you identify the zero force member and simplify the structure with a new diagram. Means if you see this one in question, you need to tell me by this statement, tell me which one is the free force member. Then you need to draw a new diagram, then start analysis. Yes, you take out the zero force member. For example, you remove AF and AB, you remove DE and DC. You will become like this. Yeah. So this is the way you simplify the equation. Okay. Sometimes this one already apply in the software. You draw something, then you ask the software to analyze. It will go and detect you will do meshing. After meshing, it will detect zero force member. Then it will eliminate the members. At the background, you will see the problem at this one. That's why the software can run very fast because it's apply this zero force member approach. Okay, all right. The purpose of having zero force is to for safety purpose and for stability purpose. Okay. So then the rest analysis will be the same like what you learned in 10 minutes ago or 15 minutes ago. It will be the same. For example, here you have 4 diagram and then you analyze, see whether it's in compression or tension. It's the same. Okay. Now you have a truss below with the force on the left, on the top left. Okay. So free body diagram at point D here. How to draw? If you have point D, how to draw? We have 90 degree. So if you don't know, you have 3 arrows pointing out from here. If you really don't know lah. Okay. So if you put pin here, can move up and down. B cannot move. So you pull pin, this will extend. This whole thing will extend. Then this one, you pull, this one cannot move, right? So this one will press on D. This one also will press. Okay. But again, if you don't know, you just draw all the arrow out lah. Then you do analysis. So at point D, you will see something like this on the screen. FDE will pull out, FDA pull out, DC will pull out. And you do all the force equals 0, x 0, y 0. You'll find that DA 0, FDC 0, FDE 0. What does it mean? They are zero force member. Yeah. So FDA is a free zero force member, but DC, DE still have value. Sorry. Okay. Can I? Once you find the force equals 0, that is a zero force member. But there's a value for DC and DE. Yeah. You look for C. C also, you draw the forces, all force point out, and you do analysis, all the force equals 0, x 0, y 0. You arrive at this one, FCA sine theta 0. Again, 2 component mathematically. Sine theta cannot be 0, so FCA must be 0. And you do FCB equal to FCB equal to FCD. So you know that this one got value, this one got value, this one 0. So this is zero force member. Okay. What can you do a conclusion based on these 2 observations? How do you find zero force member EF? this kind of scenario? Can you make a simpler conclusion based on these two cases? How you know that one is zero force member based on this observation? What is the similarity between these two diagrams? Yes. Okay. Yeah. My question is how you spot the zero force member if you have this kind of scenario? Fx zero. No. Just now, the previous one is how you know zero force member is because when you don't have reaction, right? And you already have two member. Now, what is the number of members in this example? How many members you have? 3. What happened to another 2? What happened when to another 2 and then you give another member as zero force member? What is the similarity between the top diagram and below diagram? We have 3 member, right? So there are similarity between the one of the 2 member and one member is zero force member. Can you observe the similarity? What happened to the 2 member? Same what? They must be parallel. You see parallel? Or you can see in a different direction. These two balance these two. These two also balance these two. They move in the same line. So no matter what member appeared in the middle, they are zero force member. Okay, so this is a second theorem or second guidelines to spot zero force member. First one, no reaction or only 2 member. So that 2 member is zero force member. How you spot another zero force member? You have 3 components. 2 move in the same line or in the same parallel line, in the same line or same member. And the one that in the middle always is a zero force member. Remember that. Okay, so you spot this one. You spot for the parallel line. Then look for 3 members. Parallel line, the pin with the 3 members, 1, 2, 3. You know that this one is zero force member. Then you look for this line, 1, 2, 3. These 2 member parallel or same line. This one will be zero force member. Okay, then this one you have to find the value. So you can simplify this diagram into 3 members force, three members diagram. You can remove these 2. Okay, so in the further assessment question, the first slot will always ask you to spot zero force member, identify zero force member. You need to write the statement. Either this one. You don't need to write 100% like this. But what I'm looking for is you write the one that is in blue color and yellow color. Okay. If you're using this approach, then you write this one and then you eliminate. Tell me what is the zero force member. Another one is this one. There's a statement here. Okay, here. If 3 members form a truss joint, these 2 members are collinear, means in the same line. Third members are zero members. Yeah. So the first theorem or first guideline, we look at non-collinear, means they are not in the straight line, but no external force. For example, AF and AB, they are not collinear. They are not in the straight line, but no external, no reaction force there, no loading there. So ED or DE or DC, they are non-collinear because they are not in the straight line. And There no external force at that point. So there are two scenarios. You look at non-linear members, no collinear members, and collinear members. You check these two scenarios. Okay. So you simplify the one on the left into the one on the right by spotting zero force member. Do not remove the external force. This is to simplify your analysis. Simplify your analysis. Okay. So the rest you read lah. This one is for your reading. Okay. Example 4. Use method of join. Determine all the zero force member in the truss below. Assume all join are pin connected. So this one you can by this one it asks you to determine. Determine means you need to prove your answer as calculation. But before that, you should be able to spot which one is the free force member, zero force member. Can you spot by the two guidelines just now? Can you spot which one is a zero force member? Without numerical analysis, now spot using the two statements. A and E should not have is not the first guidelines, because first guideline you cannot have a reaction. Then you look at point C. Point C, you have 4 members. So it is not the free member, right? Then you look at the second theorem or second guidelines. Second guideline, you look for the straight line, right? So straight line means you find 3 members and then look for 2 members, they are collinear. So you move from ABC straight line, you have 3 members. So which member is zero force? BH zero force. Okay. So this is a straight line or collinear. Got 3 member. A, B, C, or A, B, and B, C, they are in the collinear or straight line. This one in the middle. So BH is zero force member. Never mind. Zero force is external force is external force. Okay, because this one will transfer to somewhere. This is external force. External force, even you take this one out, force will move in the straight line also. Okay, force is a vector. You can move here, you can move here, as long as move in the straight line. Right? Then what else? Same symmetry, because it's symmetry, you know, DF is a zero force member. So once 0, 0, you take this one out already. Then you take this one 0 out already, right? You simplify, then this one you take out already, become 3 member. 3 member, this one also 0. Can you see? Can, so same, this one also, because this one 0 already. You have 3 members already. So this one 0. Then this one also 0. Because this 2 0, this 2 0, this one also 0. Because collinear. These two member and 1 member. So this one 0. Yeah. And then I'll show you the numerical lah. Okay, the rest is already explained. Okay, this is by calculation. You draw the things, then you get the zero force member. Okay. Okay. Just now got one. Yeah. Okay, so this one, GC here, we cannot conclude that GC is zero force by consider point because there are 5 unknowns. Because here got 1, 2, 3. Oh, I got 5. I think it's 3 unknown. Okay. The fact that GC is a zero force member means that 5 kilonewton load on C must be supported by member CB, this one, member CB, CH, CF, CD. Okay, so in this case, we just we have reserved this conclusion first. Then you do for other members. Okay, you do for other members. Okay. Oops. So if you do analysis, you'll find that FHC, this one is not a zero force member. Okay, so there are only 2 lah. Answer is here, only 2. You still need to do some analysis on the joint. Okay. Yes. Yes. So just be careful lah. You do analysis and prove it. If it's 0, then it's a zero force member. Okay, with this, these are your homework. Okay, method of section. Method of section is the same like the previous chapter. You cut the member into half. Like for example, this 2 force member you cut in the middle, you still see internal forces like this. Okay. Same with compression. If the member is on compression, you cut in the middle, it will still give you compression on the top, compression at the below. Okay. This is using method of section. Previous slide is method of joint. This one is method of section. You cut the things and then you tell whether it's compression or tension. Right? So like this one. This figure, you pull down 100 Newton, 1000 Newton, and with 2 reaction force here, E and D. If the members BC, GC are determined, section A would be appropriate. So the question sometimes will give you a cross section. It will cut the thing for you and ask you to do analysis by using method of section. Okay, so you should able to understand when you cut A, you should see the diagram at the below. If you cut A, you should able to see diagram below. So how you get the diagram below? You copy the C point here, although you cut, and then C point here. You pull here, and if you really don't know, you just point all the arrow out. If you really don't know, then you do analysis. All the force equals 0, x0, y0. You will find one of the value is negative. Then you flip the direction. Okay, so if you cut the 2 into half, the one on the left must equal to the right, and the arrow must be flipped to each other. Like for example, on the left, BC point to the right. On the right diagram, BC point to the left to balance the internal force. This one you already learned in the previous chapter. Okay, just want to highlight, remember to copy the reference point. For example, the member BC, there's a BC point, there's a C point there. Remember to copy the line there, because you need the length to calculate for BC and GC. You need the point for the calculation. Okay. Okay. So again, if you don't know, just assume all is tension force. If you don't know, the rest you read. And I just show you one example, then we call it a day. Right? So if you're given this structure, before you solve the external force first, the reaction force like what you did in the previous chapter. Solve AX, AY, solve BY by looking at the overall diagram first. Then you only look at the question to find the force for member GE, GC, BC, BC, and see whether they are in tension or compression. This one, if you see a cross section one, it is using the method of section already. Okay. So no lah, this one I need to remove this one. Um, um, okay. So this one you should able to draw left diagram to right diagram. This one previously to solve the external force. Okay. So your homework, you'll find the external force by all the force equals 0, all the moment is 0. Right. And careless mistakes usually here you forget to put to tell me where is your moment point. You write all the moment equals 0, then suddenly a loss of number come out. So I don't know where you refer to. Remember to put, for example, moment at A, you write MA. Okay. Then you cut the A section. Okay, the A section, you'll see all these forces, point in, point out. Then again, apply equation of equilibrium. All the force equals 0, all the moment equals 0. And pick the correct point, especially for your moment. In this case, because G is at the center of the diagram, and you don't eliminate, if you put C, then you might eliminate some of the forces, and it's not inside the cross section. So usually you pick the middle, in the middle. All right. Can you put A? Can. Can you find moment at A? Also can. No issue. Okay. So Fx, you have 3 unknown. 1, 2, 3. Because FGC, you can split into X and Y direction. Remember, if the question give you 3, 4, 5 like this, use proportional methods. So if this one, you find 500 Newton, this one, 500 Newton, FGC, 500 Newton. So this one is tension. Why tension? Because this one pull out. And they ask you about member. Don't confuse with pin. Don't confuse with the previous one. This is straight away on a member. Okay, on a member. And then BC. BC also pull out tension. Okay, this just to tell you lah, when you cut what happened, right? And so on. So this one, example 6, your homework, go and see, right? Go and see how to solve. Basically, we still keep repeating all the force equals 0, all the moment equals 0. And free body diagram, arrow point out if you don't know. Yeah, okay. Example 6, your homework, all the answer is there. This is to find the O, go home and read. Example 7, also your homework, go and see. All the answer is there. Next lecture, we look at space truss. We look at space truss, which is 3-dimensional. This one usually in the final exam. Okay. Okay, we stop here. Sign your attendance. Okay, your assignment already available on the canvas. Your question for assignment.